Scientific Notation and Conditional Probability, Part 2. Lesson Objective: Compute conditional probabilities. Let's begin. Our first example involves a standard deck of cards. Now, if you're new to cards, there are 52 cards in 4 suits. We have hearts, which are red. We have spades, which are black. We have diamonds, which are red. And then we have clubs, which are black. And each suit has an ace, 2 through 10, and then a jack, a queen, and a king. The jack, queen, and king are called face cards because they have faces on them. So again, the number of cards are 52. There are 13 hearts, 13 spades, 13 diamonds, and 13 clubs. And that sum adds up to 52. Half the cards are black, half the cards are red. A card is drawn at random from a standard deck of 52 cards. Find the following conditional probabilities. So conditional probabilities simply just means that the sample space is being decreased, that an event has happened and that event that was given is going to be our new denominator. So if you remember, probability is what we want divided by what we can get. The denominator, what we can get, is going to be restricted by this condition that happened. So let's look at number 1. The card is a club given that it is black. So our condition is the card must be black. We don't worry about the red cards. We only focus on that new sample space, only black cards. How many clubs do we have? 13. What can we get? Well, we can get any of the black cards. Well, that's 26. Half of 52 is 26. This probability would be 13 out of 26, and if you reduce that, you get 1 over 2 or 0.5. So number 2, the card is black given that the card is a club. Okay, we're given that the card is a club, so we ignore the other 3 suits and we only focus on the clubs. There are 13 clubs. Out of the 13, we want to know what's the probability that the card is black. Well, all 13 clubs are black, so that probability would be what we want, a black card, 13. What can we get? Well, we can get any of the clubs, so that's 13 over 13, which gives us a probability of 1. Notice number 1 and number 2 are not the same probabilities, so it's very important to keep track of what we're given. That is going to determine our sample space. Number 3, the card is red given that it is a club. We're only looking at the clubs, so out of those 13 clubs, how many of those are red? Well, that's 0. So our probability would be a 0 out of 13, which is 0. Number 4, the card is a jack given that it is red. So we're only looking at the red cards. That's 26. How many jacks out of the 26 are red? Well, we have the jack of diamonds and the jack of hearts. So that's 2 out of 26, which reduces to 1 out of 13. Number 5, the card is an 8 given that it is a heart. Our sample space is only hearts. There's 13, so our denominator is 13. Out of those 13 hearts, how many of them are 8? Well, there's only one 8 of hearts, so that would be 1 out of 13. Let's do another example. This is what we call a contingency table, where we have a qualitative variable here, and in this case, this is from the student survey. Do you approve, disapprove, or unsure of Trump, the variable Trump? So at this time, Trump was the president. So these are the rows. The columns is the variable party, which is your party affiliation. So number 1 asks, what is the probability selecting a student who approves of Trump given that the student was a Republican? So we're given that the student was a Republican. That means we only focus on the Republicans. This is our sample space. Everything else we can ignore. How many Republicans do we have? 34. So our denominator is going to be 34. Out of the 34, we want to know what is the probability that they approved of Trump. Well, out of a total of 34, we had 24 that approved, 4 who disapproved, 6 who were unsure. So the probability of number 1 would be 24 out of 36, and if we round that to 3 decimal places, that would be 0.706. Number 2, what's the probability of selecting a student who approved of Trump given that the student was a Democrat? So now we're only looking at the Democrats. There were 74. How many of the 74 approved of Trump? Well, that would be 2. So our probability would be 2 out of 74, which rounds to 0.027. So clearly these probabilities are not the same, which tells us that the probability of approving Trump is dependent upon party affiliation. If you're a Republican, you're more likely to approve of Trump. If you're a Democrat, you're more likely not to approve of Trump. Number 3, what is the probability of selecting a student who approves of Trump given that the student was an independent or other? Again, we only look at this group of students, 32. Out of the 32, how many approved of Trump? That would be 6. So 6 out of 32 rounds to 0.188, so about 19%. Number 4, what's the probability of selecting a student who was a Democrat given that the student disapproved of Trump? Okay, this time we're given that the student disapproved of Trump. Disapproved is here, so we see that there was 143 students who disapproved of Trump. That is our denominator. Our numerator is how many of those 143 are Democrat? Well, that would be 66. So the probability is 66 divided by 143, which rounds to 0.462. Number 5, what's the probability of selecting a student who was a Republican given that the student disapproved of Trump? So again, our denominator is 143, but this time we want to know how many Republicans. Well, that's only 4. 4 out of the 143, which rounds to 0.028 to 3 decimal places. And number 6, what is the probability of selecting a student who was an independent given that the student disapproved of Trump? Again, we're looking at 143 as the denominator. How many of those 143 were independent? That would be 19. 19 divided by 143 is about 0.133. Let's look at our last example. This is another contingency table. So the rows are drivers who use their cell phone while driving and those who do not, versus if you got a speeding ticket last year or you did not get a speeding ticket last year. So there was a grand total of 755 people in this survey. Number 1 asks, find the probability a person uses a cell phone while driving. This is not a conditional probability because we're not given a restricted domain. We just want to know what's the probability out of everybody asked that they used a cell phone while driving. So we have 755 people. Out of the 755, how many of them use a cell phone while driving? Well, that'd be 305. So our probability 305 divided by 755, or 0.404. Number 2, find the probability a person had no violation in the last year. And now, again, we're not restricting our sample space. We're still talking about the total 755 people. Out of the 755 people, how many of them did not have a speeding violation in the last year? That would be 685. So our probability would be, rounded to 3 decimal places, 0.907. Number 3, find the probability a person had no violation in the last year and uses a cell phone while driving. Okay, so this is a compound inequality. We want to know how many people are in both events. No speeding violations and at the same time uses a cell phone. So out of the 755 people, how many had no speeding violations in this group and at the same time used a cell phone? So that's how many people are in this column at the same time in this row? Well, that's 280. So out of the 755, 280 are both in this event, no speeding ticket, and at the same time used a cell phone while driving. So our probability would be 280 divided by the total 755, which is about 0.371. Number 4, find the probability a person uses a cell phone given the person had a violation in the last year. Okay, this is our first conditional probability. We're given that the person had a speeding ticket in the last year. So that means we're only looking at this group. So our sample space is no longer 755, it is 70. We ignore everything else, so we're only looking at the 70. Out of the 70 people, how many of them used a cell phone while driving? Well, that would be 25. So our probability, our conditional probability, would be 25 out of 70. And the last one, find the probability a person had no violations in the last year, given the person does not use a cell phone. Our condition is that they do not use a cell phone while driving. Well, that would be this group. So now 450 is our sample space. That is our denominator. Out of the 450, how many of those did not have a speeding violation? Well, that would be 405. So the probability would be 405 out of 450, which rounds to 0.9, or about 90%. Thanks for watching.